Everyone, welcome to Evolving Animating in Unreal Engine. I'm Jeremiah Grant, the product manager for Animating in Engine at Epic Games. A quick background on me, I come from a technical animation background. I spent the first 15 years or so of my career rigging characters and developing pipelines in both games and film. And in this role, I've had the great privilege of working closely with many animators, riggers, game designers, and other disciplines dedicated to creating engaging character performances. We really strive to create something that goes beyond the screen, something compelling, an immersive experience. But creating characters is difficult and technical. The process often pulls you out of the artistic process, and you spend more time focused on managing export settings or juggling expensive applications or creating monolithic rigs that never quite do what the specific shot requires. It's often a process of compromise. So what does the Unreal Engine do to improve this? Well, we're going to talk about 3 different ways to elevate the animation process using Unreal. First, by animating directly in context to the environment you're building, then by using layered rig systems for more sustainable and modular development, and finally by using procedural animation to create more dynamic behavior. So first, what is animating in context? Well, Unreal enables us to work directly in context, animating in the environments alongside all the other disciplines, working together in parallel towards a common artistic vision. Traditionally, everyone works in a bunch of separate silos, hoping that later on down the project, all those pieces come together cohesively. I'll be focusing on animation and rigging, but the same concept applies to all disciplines involved. By leveraging Unreal's in-engine animation and rigging tools, we're able to sculpt incredible performances without leaving our creative environment. We're going to take a look at how Sequencer, Unreal's nonlinear animation tool, and Control Rig, the in-engine rigging system, can be used to change the way we animate, rig, and build our characters. When combining these tools with Python and Blueprint scripting capabilities, we're able to create robust pipelines and customize specifically to our unique production needs. So let's take a look at this in action in the engine. Okay, I'm going to open up UE5 Early Access, and we're going to take a look at these concepts through the recently released Valley of the Ancient project. First, we have our environment here. This is the environments that we saw in the video we showed for our UE5 Early Access reveal. And I'm going to open up the intro level sequence in Sequencer. If I scroll through Sequencer, you'll find BP Ancient 1 and the control rig itself. Let's just click on a control and see what happens. All right, immediately our editor changed a little bit. We changed to the animation editing mode, which brought up this tab here. We have a couple tools available that we'll talk about in a sec. And the controls popped up in the viewport. So this is Control Rig. Control Rig is our ability to create animation controls on top of the skeleton and animate it here in Sequencer. And Sequencer here is down at the bottom. You can see our timeline, and we have keyframes shown here. If I select a control in the viewports, I can manipulate it directly and adjust my animation. Let's go ahead and play a little bit of this animation and see what's going to happen. All right, let's just pause it there. So as I play through this timeline in Sequencer, we see not only animation of the robot, but also the effects, the lighting effects, and the audio being triggered. By changing our camera to the cinematic camera, we can get the full effect. Let's keep playing. So this represents all of our disciplines working together to create this incredible shot. As we designed this moment, we were able to really explore the terrain and the character as we were introducing the robot and curate every element of this performance. This would have been very difficult to achieve in such a short amount of time without everyone working in context, especially with everyone working from home, scattered across the globe. Traditionally, we would have had to pass around versions of the geometry and iterations of the animation back and forth through different programs and praying that everyone is referencing the correct files. Any change to the ground or animation or the effects or other parts of the scene could potentially cause cascading effects through the other teams, resulting in both lost time and a lot of frustrating rework. Originally designed as a cinematic animation tool, Sequencer has expanded with a couple of features that allow us to easily create gameplay animation as well. When transitioning from the reveal of the robot cinematic to the gameplay portion of the battle sequence, we're switching from level sequences being played through Sequencer to state machine-driven animation logic being driven by animation blueprints. But the workflow change is very little for the animator. So here I have a scene up. Let's go and look at the contents and see what's happening. So these are actually a bunch of level sequences that can be played and animated in Sequencer. But every time I save this, it automatically bakes out an animation sequence, which is just skeletal animation. This allows me to animate directly in Sequencer and automatically bake out any animation sequence every time level sequence is saved, essentially replacing the process of exporting and importing from external DCCs, and that allows the iteration process to happen all in one place. So let's go ahead and give that a shot. I'm going to go to frame 45, and I'll select this control. And let's go ahead and move this. Let's go ahead and move this hand way up. There we go. So now that's what our animation looks like. I wouldn't recommend shipping that, but that'll demonstrate the process. So if I save this now, and I go and I look at my animation sequence, this hand now pops up at frame 45 and drifts back down just like our animation sequence. So this baked anim sequence that can be used through the runtime animation system is automatically generated for you. You don't need to manage exporting and importing that animation. Now, beyond just the ability to animate in engine and in context, artists also need to be supported with tools and workflow enhancements to be as effective as they can be. In UE5 Early Access, we've introduced the first of these tools here in the animation mode of the level editor. We have a couple here, a pose library, a tween tool, and a snapper tool. Let's take a look at the pose library first. So here I have a couple poses I've already created. Let's go ahead and create a new pose just so we can demonstrate the whole process. I'm going to take a couple of these controls. In fact, let's go and select them here. I'm just going to select all my finger controls, and we'll find a good pose. There we go. Got his finger kind of pointing out. So I'm going to press the Create Pose button, and we'll call this pointing right. All right. And I now have a new pose available for me. That pose is a little hard to see in this thumbnail, so I'm going to scroll down and hide my manipulators with this checkbox here, and try and frame up a better shot for this. Something like that will work. And I can just press this capture thumbnail, and it regenerates a thumbnail. There we go. All right, now that I have that that pose available, I can apply it anywhere else in my scene. In fact, let's go ahead and go to the end of this animation. And apply this new pose. I can do that by selecting this pose and either pressing the select button here, which will select the controls I want to apply it to, or I can right-click on this pose and select the controls. Now, I don't have to apply this pose to the entire thing, but let's do that first. I just clicked the Paste Pose button, and it applied that pose to my fingers. Now, maybe I immediately regret that, and I want just to apply it to all the fingers other than the thumb. I'll just deselect the thumb controls here and press the Paste Pose now, and it'll just paste to everything but the thumb. Additionally, rather than just pasting to the controls that were initially saved, I can mirror this pose. So I'm going to press the Mirror Pose button and click Select. That will automatically find and select the mirrored versions of these fingers based off of our mirror settings here. Let's go ahead and paste the pose here. There we go, and now we have the pose on both sides of our character. In addition to the pose library, we also have a tweening tool and a control rig snapper tool. These can let you drive your controls, either fix them through a period of time and space, or be able to adjust how the controls are animated based off the previous and future poses set in your timeline. As with the rest of Control Rig and Sequencer, the pose library and animation tools are exposed to Python and blueprints, allowing to write custom tools specific to your workflow. All right, with that, let's jump over into the Control Rig editor and see what goes on in making this rig for our giant robot. All right, here we have the Control Rig editor. Control Rig is a node-based rigging system where you can create relationships between controls and bones or curves. In this case, we are getting the transform of a control and setting the transform for a bone. Now, for the ancient, we used the metahuman skeleton as a base to start from, adding on additional bones for armor, pistons, mechanics, and other elements we wanted to be able to drive. By taking advantage of Control Rig setup mode, we were able to immediately adapt a rig designed for a metahuman rig to the proportions of our massive robot. Now here's our setup event, and what we're doing is stepping through all of our hierarchy. We're just getting the initial transform of each bone and setting the transform of the controls. So this is actually placing the control locations to align themselves with the bones. So before any animation takes place, the controls are in the right location and they're able to drive the bones from their initial position. So if you're importing in a skeleton externally and you want to snap all the controls to the correct locations, you can use the setup event to do that. You can also use the setup event to initialize variables or settings for your rig. In this case, I'm just creating collections of items, and for instance, all of the finger bones and all the finger controls here in the setup event, so I can call those collections later on throughout the rig. Looking at the rest of the editor, we get a sense for how we end up creating this rig. We have a rig hierarchy here, which is a hierarchy of controls of various types. We have a skeleton hierarchy here. This skeleton was actually imported in as our base skeletal mesh. So this has the geometry and the bones. We are able to import in skeletal mesh just through this right-click menu here. And I can create a new control just by right-clicking and saying New Control. There we go. So now I have a new control, and I can look at the details here. By default, it's creating a control type of transform, but you can have controls of float, integer, vectors, rotators, bools, any number of types here. And all of these control types can be animated in Sequencer. And in the case of this rig, we actually have a bunch of Boolean switches that can be animated to turn on and off your IK or FK, toggling between those modes. You also have a control here for changing the body controls. I can toggle this right now and see the results there. Let's go ahead and change the IK and FK for the arm. Let's go ahead and put that a little bit more. So here I'm just going to change my arm, and we'll go back to my right arm IK. And as I toggle this, it's automatically snapping all the IK controls to match the pose of the FK control. All of that is happening directly here in Control Rig. Now, as I zoom out, you get a kind of full glimpse of this rig. There's a lot going on, including a backward solve graph, a forward solve graph, and our setup graph. Now, Control Rig also enables us to create a backward solve graph, allowing controls to be driven by the bones themselves. This essentially is baking skeletal animation to the controls. This is super helpful in mocap scenarios where you record motion capture and you want to bring that animation into the engine and continue iterating on it with the animation rig. Now I can preview that here in the Control Rig editor by changing my mode to backward solve. We see that this line now highlighted, and this is the event that's being run. If I go into my preview scenes and change my preview controller to use specific animation, I can preview an animation real quick and see the controls animating along with my skeletal animation. If I pause this and I select a control, I won't be able to move this control because it's actually the bone transform being evaluated in this graph to set the transform of the control itself. Now let's go back into the level editor and take a look at how we can use this backward solve functionality in Sequencer to iterate on our animation, whether it's mocap or imported animation using Control Rig. So here I've actually just created a new level, nothing in it, so we'll be able to start from scratch. I'm going to go to the content drawer and going to find our BP Ancient 1 actor, drag this into our level. I'm just going to frame it, and I'm going to press G so I'm not seeing all the gameplay stuff going on. Let's create a new level sequence. That's the perfect location. And let's drag in our blueprint in here. I'm going to press the plus on the track and add in an animation. Let's go ahead and do the charge animation. Now in this case, this animation was created in Engine, but if it had been recorded elsewhere, this is how we would iterate on it. There we go. So I just adjusted the frame range so it's only for the duration of this animation, and as I play through it, we just have the animation playing. There we go. Now this is baked animation. Again, this is the actual animation sequences generated from our linked animation sequence. But in this case, since it's just baked skeletal animation data, I can right-click on the actor and say Bake to Control Rig. It will automatically find control rigs that have a backward solve graph that's using this skeleton. I can change some of the settings of where to search and what to look for here. Now I'm going to choose our one available control rig here. It gives me some quick options. Do I want to reduce the keys? And what tolerance do I want to use for reducing those keys? I'm just going to check that off so we have a one-to-one solve of this. And then as I scrub through my animation here, I now have my controls animating, and I can select these controls and see the animation here. You can still see the original baked animation sequence here. All we did is muted that sequence, so it is no longer active. If you ever need to get back to your original animation and not use your control rig animation, you can do that just by selecting your control rig track, deleting it, and right-click and activate your animation again. And now you're back to your original imported baked skeletal animation data here. Now, let's pretend that we don't have a control rig with that baked data, or with that backward solve graph available for us. We can still edit our animation here in Sequencer. We can do that by right-clicking on our actor and going to Edit with FK Control Rig. We get a similar dialog, Bake to Control Rig, but this instead is going to bake to an automatically generated control rig, which you can see here. It's going to have a control representing every bone, essentially giving you the direct bone FK rig to manipulate. You may not want to manipulate all of those things, so you can always right-click and toggle which controls and what tracks you want available here in Sequencer. Control rig is the underlying framework that is enabling us to evolve the way we rig and animate. It allows us to feed in information about our environment, enabling us to author dynamic and responsive performances. Traditionally, rigging systems are built as modules and baked into a more monolithic structure before being handed over to the animator. This means that any change to the rig can potentially break all the other animations. Additionally, the animator and rigger are siloed from each other, not adhering to our working in context theme. The Unreal Engine gives us the ability to build rigs in layers. By building in layers, we're able to add levels of complexity at any point, working in small, bite-sized pieces. One way to do that in Unreal is by using post-process graphs. So let's go back into the engine and see what that looks like. So this is a post-process animation blueprint. The only difference between this animation blueprint and an NMVP that is more commonly used is where it's being evaluated. The graph will run after all other animation, state machines, gameplay logic, or even sequencer animation has been processed. In fact, we can already see this in action if we go back to the level editor. Notice how the gears are automatically spinning here. And if I grab this hand control, the pistons are going to automatically compensate for the arm movement. All of that is being taken care of by separating the rigs and using post-process graphs. And by doing this, the animator can start creating performances faster, and the rigger can build out the needs of the rig into independent pieces. Now, going back to the post-process graph, we can dig a little deeper into what's happening. First, we're grabbing the incoming pose and storing it as a cache. This is going to be our sequencer animation or our gameplay animation. This step isn't essential, but in this case allows us to be more specific about how we're applying our additional layers. Then we're feeding that input cache into our control rig and into a rigid body node. We're able to blend those two together using this layered blend per bone node before we're outputting our pose. Due to the way we animated the robot, we wanted to be able to control when the physics were enabled on the front skirt armor. By breaking out the rigid body physics of that front armor, we were able to be very specific about when, where, and how much was being applied. We're blending that on with this physics-enabled float value here into the layered blend per bone node. The control rig also takes a parameter called gear weights. When the robot is destroyed, we want the gears to stop spinning. So we feed in a gear weight value for the control rig to read. This value is being set in the event graph and is being fed in by the BP Ancient 1 actor blueprint here. This allows us to drive our animation rig directly from gameplay, something we'll talk about a little bit more later. Drilling into the control rig here, we find the mechanics setup. We're controlling pistons, gears, armor, and other things we don't want the animator to have to worry about. Since we have fine control over every element of this rig, we can apply additive or absolute adjustments to any part of the character, responding directly to the context of the performance and gameplay needs. Another benefit of working in this way is we're able to create animation that automatically blends through other incoming animation, essentially removing part of the baking process. This also enables our character to be more dynamic and responsive. For example, if the spinning gears were baked animation, then they would pop depending on when we interrupt the idle animation to transition to a fire animation. By using post-process graphs and control rig, this isn't a problem. This brings me to using procedural animation as a tool. In gameplay scenarios, we're used to adding in layers of physics simulation, IK compensation for foot and hip placement, and many more procedural systems to make our content come alive and feel immersed in the world we've built. In Unreal, we're able to accomplish these things without requiring you to write any code and in a way that can be shared and applied to any character on screen. Control rig is unique in that it is always live and running, allowing you to take advantage of the rig evaluation to create procedural and dynamic behaviors. In the Valley of the Ancient project, we use full body IK to layer on a full posture adjustment depending on where the player is in the battle arena. The position of the player and a multiplier for how far we want the robot to reach is passed into the control rig, allowing us to drive this behavior during gameplay. By using a procedural system to achieve this, we don't need to author unique aim offsets for all conceivable positions the player may be in, and the Ancient feels like a grounded and integrated enemy to encounter. So, where do we go from here? Just because the experiences we create are complicated doesn't mean the process has to be complex. By working in context, building up small layers of complexity, and moving away from baked, siloed workflows, we can spend more time creating and less time working. In short, you can tell your stories faster. Thank you for watching. You can contact me on Twitter at Jeremiah3D. I look forward to interacting with you all and hearing your thoughts on how we can continue evolving the animating process.